In the following pair of halogen compounds, which compounds undergo SN1 reaction faster? This we are going to discuss. First one we have tertiary butyl chloride. Second one, Cl is attached to secondary carbon. So it is 1, 2, 3, 4, 5, 3-chloropentane. So out of these, which will react faster? Answer is tertiary butyl chloride will react faster because it will form tertiary carbocation, which is more stable. This will form secondary carbocation, which is less stable. Here we have secondary and this one we have primary. So naturally secondary will react faster because it will form secondary carbocation, which is less stable than primary carbocation. This is 1, 2, 3, 4, 5, 6, 1-chlorohexane. This is 1, 2, 3, 4, 5, 6, 7. This is 2-chloroheptane. We are giving you written explanation. Tertiary halide reacts faster than secondary halide because of greater stability of tertiary carbocation. Similarly, secondary halide will have more stability. Secondary carbocation will have more stability than primary carbocation. Therefore, this will react faster. We have to identify the products in the following reactions. Here we have 1-bromocyclohexane. We are reacting with Mg in the presence of dry ether. A is formed which reacts with water to form B. Here we have Br which reacts with magnesium. Dry ether C will be formed with D2O. You will get this product. And here these we have to identify. DE we have to identify. Let us solve this problem. This is 1-bromocyclohexane when reacts with magnesium in the presence of dry ether. Dry ether is must because the product formed will react with water. So this we get cyclohexyl magnesium bromide. This Mg will form bond here. So this is cyclohexyl magnesium bromide. Now we are reacting with water. This bond will break. OH ion we will give to this so that you get hydroxy magnesium bromide. H we will give to this carbon so that we get cyclohexane. Here we have got 2-bromopropane which reacts with magnesium and we get isopropyl magnesium bromide. D2O will break down into D and OD. OD will combine with MgBr to form deuteroxy magnesium bromide and D will be attached to this carbon from where MgBr has been removed. So we get deuteropropane as the product. In next reaction, this we had tertiary butyl halide. We react with magnesium, so corresponding Grignard reagent will be formed, which is tertiary butyl magnesium halide. When we react it with water, this bond will break, hydrogen will get attached and OH will be attached to magnesium halide and it will result in the formation of hydroxy magnesium halide and we get isopropane. Here, the tertiary butyl halide is undergoing Wurtz reaction with sodium metal. 2NaX will be removed and this product will be formed. This is 2,2,3,3 tetramethyl butane is the name of the product. So A we have identified cyclomagnesium bromide, B we have identified as cyclohexane, C is RMgBr and R is isopropyl group, R dash is tertiary butyl group, D is tertiary butyl magnesium halide and E is 2-methyl propane. Next question, name the following halides according to IUPAC system and classify them as alkyl, allyl, benzyl, primary, secondary and tertiary, vinyl and aryl halides. So the first question we have got CH3 twice CH, CHCl, CH3. The first step is to write it in this form. This CH is attached to 2-methyl group, so attached 2-methyl group here. This CH is attached to Cl, we have attached to Cl and this CH3 is here. Now start counting from this side because halogen will be preferred over methyl group. This compound is 2-chloro-3-methyl butane. Butane because 4 carbon atom we have counted. Second carbon there is chloro group, third carbon there is methyl group. Now Cl is attached to secondary carbon, that's why it is called secondary halide. Second, here also we are converting into this structure. CH3 remains as it is, CH2 remains as it is. This CH is attached to CH3. This CH is attached to Cl and C2H5. CH2H5 we have expanded as CH2CH3 so that we can get the longest chain possible. First carbon, second carbon, third carbon so that Cl gets minimum number. Fourth carbon, methyl group gets number 4, 5, 6. So 3-chloro-4-methyl-hexane is the name. This is also secondary halide because Cl is attached to secondary carbon atom. This compound, let's convert into proper structure. CH3 comes here, CH2 comes here. This C is here. It is attached to 2-methyl group, one above, one below, and CH2 is attached here. CH2I. This is the first carbon because it is attached to ido, which is functional group here. 1, 2, 3, 4. 1 ido, 2,2-dimethyl butane. Total carbon atom are 4, that's why it is butane. Second carbon, 2 methyl groups are attached, we call it 2,2-dimethyl, and ido is attached with the first carbon. Therefore, first carbon means primary carbon, therefore it is primary halide. Next question, this CH3 thrice C, we write one carbon attached with 3 methyl group. CH2 remains as it is. This CH is here, Br we have attached here, C6H5 is here. Now counting will start from this side. 1, 2, 3, 4. 1 bromo. This is 1 bromo. 3, 3-dimethyl. This is 3, 3-dimethyl. 1 phenyl with the 1 carbon C6H5 is attached, which is called phenyl. 4 carbon we have counted, we call it butane. This is called benzylic halide because here C6H5 group is attached and then CH is attached. Whenever this group is there, we call it benzylic halide. And this is secondary one and not primary because Br is attached to secondary carbon. Next compound CH3 is as it is. CH3 we have written in this form. CHBr we have written in this form, and this is CH3. Counting will start from this side so that Br is preferred. So it is 2 bromo 3 methyl butane. It is secondary halide because Br is attached to secondary carbon atom. Next compound, this CH3 is as it is. This carbon is attached to 2 ethyl groups. So we have attached 2 ethyl groups, CH2Br. Here also it will be difficult to name. So we are expanding this C2H5 as CH2CH3. Now start counting from this carbon which is attached to Br. This is first carbon, second carbon, third, fourth. Now 1 bromo, 1 bromo. Second carbon ethyl group is attached to ethyl. 2 methyl group is attached, so 2 methyl butane because 4 carbon atom we have counted. Here this compound is primary halide because Br is attached to primary carbon atom, that's why it is primary halide. Now let's name this compound. Here CH3, this is CH3, this is C, this is C, it is attached to Cl, this C2H5 we have written here, and this is CH2, CH3. This is the C2H5 we need to expand to CH2, CH3, which we have done in this structure. Now counting will start from this carbon. 1, 2, 3, 4, 5. Third carbon, chlorine is attached, 3 chloro. With the third carbon, methyl group is attached, 3 methyl group. Total carbon atom counted 5 pentane. So it is 3 chloro, 3 methyl pentane. This is tertiary halide because Cl is attached to tertiary carbon atom. Next question. Here we have got double bond. CH3 is here, CH here, double bond here. This carbon is attached to Cl, this carbon is attached to Cl. CH2 is here, CH is here, CH3 twice you will expand, CH3 here, CH3 here. Now start counting from this side because double bond must get preference. First, second, third, fourth, fifth, sixth. Third carbon chloro group, 3 chloro. Fifth carbon methyl group, 5 methyl. Double bond is after second carbon, and total carbon atom are 6 hex 2 ene. This is vinylic halide because this structure is of vinylic halide because double bond and Cl are attached to the same carbon, so we call it vinylic halide. Here CH3 is as it is, CH here, double bond CH here, this carbon is attached to Br and 2 methyl group we have attached here. Counting will start from this side because double bond has to be preferred over bromo as well as methyl group. So this is first, second, third, fourth, fifth. 4 bromo, 4 methyl, pent, 5 carbon atom, 2 double bond is after second carbon, ene because double bond is there. This one is tertiary halide because Br is attached to tertiary carbon, but this is allylic halide. Allylic means that this is attached to the next carbon. Br is attached to this carbon and double bond is attached to next carbon. So then it is called allylic halide. Let's name this compound. C6H4 means benzene ring. Para Cl means at fourth position Cl. This CH2 here, CH here, 2 methyl group, 1 methyl here, 1 methyl here. How to name it? 1 chloro 4 2-methyl propyl benzene. Here parent we have taken is benzene and chlorine will be preferred, therefore we call it 1-chloro. At fourth position, this group is 1, 2, 3. It means 2-methyl propyl benzene is parent. This is an example of aryl halide. Next is also aromatic. C6H4 means benzene ring. CH2Cl at meta position, CH2Cl at third position. CH2 here, CH2 here. This carbon is attached to 3-methyl group, 1, 2, 3. Now again parent is benzene. This group is chloromethyl, which is at first carbon, therefore we call it 1-chloromethyl. This is third carbon, we have written third. This is 2,2-dimethyl, this is second carbon, so 2,2-dimethyl. Propyl, this is propyl. Benzene is the parent, this is benzylic halide. CH2Cl is called benzylic halide. Whenever CH2Cl is attached to benzene ring, we call it benzylic halide. And this is primary benzylic halide. Here we have got C6H4, we have made benzene ring. Orthobromo means second position bromo to this alkyl group. So here CH, CH3, this CH, CH3, CH2, CH3 we have written here. Now while preference, bromo will get preference because this is the major functional group present on the benzene ring. So it is 1-bromo, this carbon is second carbon and this group is 1-methyl propyl because this is first carbon, first, second, third, 1-methyl propyl. Benzene is the parent. This is also called aryl halides because Br is directly attached to benzene ring.